Hello everyone and welcome to today's video. You'll remember from my last video that we had a look at how to do a simple character movement in the Godot Game Engine using the left and right arrows on the keyboard. And I was wondering to myself, how easy would it be to do the same thing in the Unity engine? And I thought, let's give it a try. So in today's video, we're going to compare Godot to Unity and see how easy it is to do the exact same thing in the Unity engine. Get ready, let's have some fun. Right everyone, so what I've done here is I've opened a new Unity project, and this is the screen you'll get when you start any blank project. We're going to be doing the same thing we did in the Godot engine. All we want to do is get a simple character moving from left to right using keyboard controls. Our character is again going to be a sprite, and we can just drag any game asset that we have and drop it in over here. So this is our airship again that we're going to use, and there we have it. If I drop it on the hierarchy, it adds the airship as a sprite. You can see it's a sprite renderer here, and we have the airship. Once again, it's too big, it's filling up most of the viewport, so what we'll do is scale it down to a quarter of its size again, 0.25 on the X and 0.25 on the Y, and that's a better size for the screen that we're working with. What you'll see is that Unity is actually a 3D engine, which means you need a camera to be able to see what's happening on the screen, which is why we've got a camera here. So although we're doing a 2D game here, we'll still see the Z-axis because Unity is actually a 3D engine. Alright, so we have our airship in, and we want to be able to control him. In order to do that, we're going to have to add a script to our project. So we can just right click and say create C# script. There it is, and let's give it the same name as our sprite. Let's call it airship. So there it is, and we get a little preview of it. If we want to edit it, we're going to have to open it in some kind of editor. Most likely the editor is going to be MonoDevelop or probably Visual Studio. So I'm going to double click, and here we have it open in Visual Studio. We'll do the same thing we did in Godot. We'll create our own little move method. So we'll create a method here called move, and so that we don't forget to call it in the game loop, which is the update method in Unity, we'll just type move over there. Okay, and now it will run. Now what does move do? Well, we want to control our little character with the keyboard. So firstly we need to find out which direction he's moving in. In order to do this, we'll create a little variable that can store that information for us. So we'll say float move direction, and we can go to the input system, and we can say get, I think it's capital G here, get axis, and we want the horizontal axis. So we're going to say horizontal. Now it's going to tell us that what will be stored in that float variable there, move direction, is either a -1, a +1, or a 0, or a negative value, positive value, or 0. If it's 0, he's not moving at all. If it's negative, he's moving left. If it's positive, he's moving right. Okay. Then what we need to do is actually move him around. So let's go ahead and say if our move direction is greater than 0, that means we're moving right. And what we'll do is, if we move right, we need to change the transform and specifically translate the coordinates of the sprite as a new vector 2. That means its direction and its speed. And the two components are the direction will be right, and how far right? Well, it's going to move very fast across the screen because we're not normalizing it with speed, which I'll show you in a minute. So we'll just use a very small value and see how it works out. Okay, and what we'll do is if our movement direction is less than 0, that means we're moving left, then we're going to do the opposite. We're going to say our transform dot translate is a new vector 2, and we're going to again say this time it'll be in the negative direction, so 0.01 f for float and 0. Okay, so let's save this and return to Unity and run the project and see if we can move right. And it doesn't seem to be working, so we'll just have to go and check what we've done. Okay, so let's go back to our we haven't attached the script to the sprite. So what we need to do is grab this script over here and drop it on the airship, and now you'll see you have the airship script over there. Okay, so now we should be able to see what happens. If I press right, he flies to the right. If I press left, he reverses. Now that's exactly what we had in Godot. A little bit simpler in my opinion to do it in Godot because you're dealing with a position and you're not having to deal with these computer science terms like translate, the translate property of a transform, and deal with vector 2 and so on. But we've got the same effect. Let's just go and make it so that when he turns left, he faces left, and when he turns right, he faces Y. What we're going to have to do is flip his X coordinate. Okay, so if we go back to our script, if he's moving right, well, the default is to face right, so we don't need to flip him. But if he's moving left, we do need to flip him. In order to flip him, we need to access that game object, that sprite renderer. So we're going to say create a little local variable of the sprite renderer. Sprite renderer, we'll call it SR. It's going to be equal to, and we'll get the component and the component is a sprite renderer. Okay. Now we can access the properties of the sprite, and we'll say sprite renderer dot flip. The X is false if he's moving right, because we don't need to do anything if he's moving right, and sprite renderer dot flip X equals true if he's moving left. We do want to reverse him if he's moving left. Let's see how that looks. We go ahead and play. We're moving right, left, yeah, we get him turning around. Neato. Okay. The last thing we did in Godot was to add a background. That is pretty easy to do in Unity. You just drag it, drop it on, and we can make it take up the entire background like that. I think if we move these, actually it's under the shift below. Order, it should be number 1. Sorry, which one? Airship. It should be the first one. Yeah, there we go. Okay, so now we've got the background, and we can still fly across the background. Nothing's changed. What we could also do is we could add a speed. Right, we could add a speed variable to our ship here. So we could add another variable here called speed. Let's call it an int called speed. Let's make it 4, right? And then if we wanted to use this speed variable, we could, instead of this line here, we could do something like similar to what we used in Godot. We could use the transform dot position, right, equal to the transform dot position plus, and we can say transform dot right. That gets rid of us having to do all this translate business and use the vector, but that's going to just shoot him straight off the screen in one touch of the key because of how fast the CPU processes. So what we need to do is smooth out the movement and slow it down using the time that's elapsed between frames, which is called delta time. So we can multiply this by time dot delta time, and we can also multiply that by our speed variable. That way when we change the speed variable here, it will affect his speed. So just to say what this does, multiplying our right movement by time dot delta time, it just makes sure that you can see the movement and that it's not zipping across the screen at the full speed that the processor can work. It just slows it down, smooths it out so that it's visible. So if we go back to Unity and run it, semicolon, what did I leave off? Sorry, so used to GD script, forget my semicolons in C#. Run it again. Let's just see another problem. What have we got here? Transform dot position is equal to transform. Sorry, it's equal to transform. Let's just do this. Instead of doing that, let's say transform dot position plus equals transform dot right times time dot delta time times speed. That should work. Let's save it and see. Let's test it. Okay, so now when I move right, you can see he moves a lot faster than when he moves left, because we're multiplying by speed for left. Okay, and you can see the difference there. Right, so in conclusion, which is easier? In terms of dragging and dropping things in Unity, that was probably easier because I didn't have to go and create nodes, although I could just drag and drop it in Godot. Okay, I'm going to say that's a tie in terms of importing the assets and so on. The actual coding to get it working, pretty similar. I think GD script is nicer because you don't need all these braces and semicolons. You decide. Let me know in the comments which one you think was easier to work with, Unity or Godot, and did we achieve the same thing? Once again, thanks for joining me, and I hope to see you again next time. Like and subscribe if you haven't already. Goodbye.